Yesterday we went over the two easiest types of mole equation problems. Today we're going to go over the ones that are almost as easy but have one extra step. Okay? It doesn't actually make them any harder, it just has one extra step to complete it. All right, so these are usually worth between 4 and 5 marks. Okay? So for this one, as with all mole equation questions, our first step is to write down our givens. It's asking for something we haven't done yet. It's asking for how many molecules there are. Okay? Is that part of the mole equation? Yesterday we learned the mole equation can calculate the number of moles, or the mass, and we can always calculate the molar mass from the periodic table. Okay, so that equation won't tell me how many molecules of something there are. But we did learn about this number as well. Okay, this is Avogadro's number. It's the number of particles in 1 mole, be those atoms or molecules, whatever we're dealing with. Okay, so that's how many molecules are in 1 mole. If I want to figure out how many molecules there are in 600 grams, I should be able to do that if I have this number, which I do. And you will also have it. It's on your periodic table, and it's on your unit exam on the front page. Okay? All right. If I want to calculate the number of molecules, I'm going to need to know the number of moles. Okay? If I know the number of moles, and I know that there's this many molecules in 1 mole, can I use those two numbers together to figure out how many molecules I have?
Yes.
Yes. How would I do that?
You calculate the number of moles and just multiply it by Avogadro's number?
Exactly. I would take the number of moles and I would multiply it by the number of molecules in 1 mole. This intimidates people. They look at this number and they just blank on math because they're like, it's a big number. Okay? How many donuts in 4 dozen donuts?
48.
How'd you do that? You went 4 times 12. You said, I have 4 dozen, and a dozen is 12. 4 times 12 is 48. We're doing the same thing here. Okay? Number of moles, number in 1 mole. And we're multiplying the 2. Okay? It's exactly the same as that simple calculation you did because you weren't intimidated by 12. Okay? This is a small number and it's something you're familiar with. Okay? This works just like 12. Okay? It's like a dozen. This is the number in a mole instead of a dozen. Okay? Everyone all right with that analogy? Okay. So here are our givens. We are looking for the number of molecules. Okay? We know that we have 600 grams. Okay, what did they just give me there? The number of grams, which is which part of the equation?
Little m.
Little m, right. The mass. Okay, and then they told me it's silver nitrate, which means I can use that to calculate the molar mass using my periodic table. But they gave it to me in word form, which means I have to be very, very careful. I have to get the formula right, or I won't get the right molar mass, I won't get the right number of moles, I won't get the right number of molecules. I won't get anything right. Okay? So we don't want that. So this is silver nitrate. So silver, which is a +1, okay, with nitrate, NO3, which is a -1. All right, perfect. Drop and swap, done. Now I just have to calculate my molar mass. So silver's 107.87. 107.87 is silver. How many nitrogens are there?
1.
Just 1. Plus 14.01. And there's 3 oxygens, so that's 16 times 3. Okay. Sorry, I should have fired up my calculator before. It takes a while to load. Alright, So 107.87 plus 14.01 plus 48. Okay, 169.88 grams per mole. Okay, so I have little m and I have big M. Can I calculate the number of moles? I sure can, right? I've got the other two parts of the formula. So I'd get 1 mark for this step, same as I did before, writing out my givens. Okay, I'd get another mark for calculating the number of moles. So that'll be 600 grams, the mass, divided by 169.88 grams per mole, the molar mass. Okay, and that will give me 600 divided by answer. Whoops, that's multiplied. Won't work. All right, 3.53 moles. Okay, so now I know the number of moles, 3.53. Now, I rounded this off. When you're doing your calculations, keep all the decimals in your calculator. Okay, that's what you're always going to have to do going forward in chemistry, in physics, in biology, whatever. You keep all the decimals, and then at the end you can round off to the right number of significant digits, which we are not covering till physics. Okay, but I just want you to get in the habit of keeping all your decimals. Okay, so I've got 3.53 moles. Now, as we said, if I want to calculate the number of molecules, I take the number of moles and I multiply by Avogadro's number. Okay, and that will give me my number of molecules. So that's going to be 3.53 with all the decimals that are still in my calculator times 6.02 times 10 to the 23. Now, how do you punch that number into your calculator? I'll show you. Okay. If you have any of the TI 80 through whatever number we're on now, okay, here's what you do. So I'm going to take this number here, okay, and I'm going to multiply it by Avogadro's number. Regardless of what kind of calculator you have, you need to put Avogadro's number in brackets, okay, so that it's isolated all by itself. So brackets 6.02. Now, your calculator may have one of several buttons. It may have a button that has 2 capital E's. That's what the TI has, okay? But it's the second function of this button. So if you have a TI, you've got to go second and hit the comma. And it'll give you this little E. The little E means times 10. And the next number you write in is the power of 10 that you're using. In this case, that would be 23. Okay? If your calculator doesn't have that, it may have an EXP button. Okay? Like in capital letters, EXP. If it has that, press that button, that will give you the E, and it means times 10. Okay? Or it may even put times 10x as a little indicator up in your calculator. Okay? And then you enter your 23 and close the brackets. Okay? So your calculator may have one of many different buttons to perform that function.
So the E is just equal to 10.
Yeah, the E means times 10, and then the next number is whatever power is on the 10. Okay? That's the way they represent it. What I don't want you to do is go times 10 and then go to exponent and go there. It always messes up. Okay? And some people, they hit the, I can't remember what button it is, and it gives them like another exponent. They go times 10, then they hit this button and it gives them another exponent, and it ends up putting in an extra factor of 10 because they put in the times 10. You don't have to put that in. Okay? Use the E symbol, 23. Okay? If you can't find a button on your calculator that's looking like what I've described, I'll come over and give you a hand and find it for you. Okay? But it's usually 2 capital E's or 2 small E's or EXP. One of those 3 is usually what that button looks like. Okay? So it would be advisable, because I see a bunch of you still using your phone as a calculator, get yourself your calculator that you're going to use soon, because you don't want to be getting it the night before the exam and not be familiar with its use. Okay? And then on the exam, you're like, Mr. Coder, I can't find that little button. And then you're wasting time. Okay, so we don't want that to happen. All right. So now, when I punch that in, it says 2.13 E24. So it's 2.13 times 10 to the 24. Okay. 10 to the 24 molecules. Okay? Everybody all right with that? How important are units? Very important. Make sure they're on there. Okay? The units are molecules. Okay. Everybody all right with that one? Right, so all it has is this extra step. You just use the mole equation, okay? N equals little m over big M, and then you have this extra step where you multiply by Avogadro's number. So this would be a 4-mark question. You get 1 for your givens, okay? You get 1 for calculating the number of moles. You get 1 for this operation where you're multiplying by Avogadro's number, okay? And you would get 1 for your final answer for a total of 4 marks. All right. The last way I can ask you a mole equation question is the exact opposite of this. I give you the number of molecules and ask you to calculate the mass. So you do everything backwards. Okay? And then you'll get a recipe. All right, so write that one down. We'll walk through how we do that one. All right, so question number 4 is asking us to calculate the mass. Okay, mass is obviously part of the mole equation. If I'm going to calculate mass, which is little m, I need to have molar mass, which I can always get from the periodic table, and I need the number of moles. That I don't have. The question doesn't tell me that. Okay, the question tells me that I have a certain number of molecules. Okay, 1.54 times 10 to the 25. Okay, and it tells me that the material I'm dealing with is diphosphorus tetraiodide. Should I reduce that?
No,
because it's molecular. Okay? All right. It's instant is yes, we should, because Coder asked if we should. The answer should be yes. No, it's not. The answer is no. Okay? We don't want to reduce it. It's molecular. We would reduce an ionic compound if it came out like that, but because the prefixes said it was 2 and 4, we keep it that way. All right, so we've got 30.97 for our phosphorus. Weird. Okay? And there are 2 of them. And then we have 4 iodines, and that's 126.9. And there are 4 of those. All right, 569.54. Grams per mole. Okay, so now I've got that. Now what do I do? I still need the number of moles. How am I going to get that? I have 36 eggs. How many dozen eggs do I have? 3. How'd you do that? You divide it, right. You went 36 divided by 12, because 12 is the number there are in a dozen. I'm going to do the same thing here. The number of moles will be the number of molecules divided by Avogadro's number. okay? Because this is the number of molecules in 1 mole. It's like 12, okay? So I'm going to divide those two numbers to get the number of moles. Okay? That you won't find on your periodic table. You won't find it on your data sheet. That's just something we expect you to be able to figure out, or worst case scenario, memorize. Okay? All right, so number of molecules is 1.54 times 10 to the 25 divided by Avogadro's number, 6.02 times 10 to the 23. All right, so in my calculator, that's going to look like this. In brackets, 1.54 E 25 divided by, in brackets, 6.02 E 23. So I have 25.58 moles. All right, so now I have N and I have big M. So now I can calculate mass. So I'm going to take the mole equation and I'm going to manipulate it for little m. How do I do that?
U times big M on both sides.
Right, multiply both sides by big M. Right? And you'd get a mark for that. Sorry, I didn't show you where all the marks are. Okay, 1 mark for givens, same as always. 1 mark for calculating N. Okay, 1 mark for your manipulation. 1 mark for putting in your numbers, so that would be 569.54 times 25.58. Okay, I have a lot. That's almost 30 pounds. Okay? It's 14.5 kilograms of this stuff. Okay, that's a lot. And so we're going to write in 14,569.63. grams. Okay, and then you get a mark for this and a mark for your final answer, so that one would be a 5 mark question. Listen.
Are we expected to be able to convert it into kilograms?
No, you can leave it in grams. I would expect that, yes, you can make that conversion. Metric conversions are something that we expect as a prerequisite skill you already possess. Okay, so when we get to the physics unit, going back and forth between meters and kilometers and centimeters and meters is going to be something we expect you're able to do.
Well, I'm just supposed to write it as grams?
Oh yeah, you can write it as grams, yeah. I mean, whenever we're dealing with chemistry, we always write grams. Grams is the units for chemistry. Okay? In physics, we deal with very big things, so we always use kilograms in physics. We deal with stars and planets and galaxies, big stuff. Grams is useless. Yes. Okay, questions on what we did there? Okay, so now you've seen one example of all 4 types of mole equation questions that I could ask. So what I want you to try now is these ones. Okay, so now that you've seen one of each, I want you to try these, and then I'll walk through them one at a time, okay, as our second set of 4 examples, because I promised you that's what I was going to do. All right, so looking at the first one here, we're looking for how many moles? So we're looking for N. They tell us it's carbon dioxide, so that's CO2, right? And that's going to be 12.01 plus 16 times 2, which is going to be 44.01 grams per mole for our molar mass. Okay. They also tell us the mass is 150 grams. Okay, so N equals little m over big M. That'll be our mass, 150, divided by 44.01. Okay, so this is grams per mole. So when we do that, we're going to be left with moles, 150 divided by 44.01. We're looking at 3.41 moles. on that one? Don't be afraid to ask, guys. All right, how many people have done the second one? Okay, let's look at the second one too then. Okay, so for our second one, we're looking for the mass. So we're looking for a little m of 26.5 moles, so that's N, of cobalt-2 bromide. So CO with the 2 plus charge, with bromine, which is a -1, so we're looking at COBr2. Cobalt is 58.93. And we got 2 bromines, so 79.9 times 2. Okay, so we're looking at 218.73 grams per mole. Okay, so those are our givens. N equals little m over big M. I'm trying to solve for little m, so if I want to move something, I do the opposite. So I multiply by m. What I do to one side, I do to the other, so I multiply the other side by m as well. And now I've got my formula. So mass will equal 218.73 times 26.5. Okay, so we're looking at 5,796.35. Grams for our mass. Questions on those two? All right, do we still need a little more time on 3 and 4?
Yep.
Okay, so on number 3, we're looking for the number of molecules. So this one's going to involve that extra step using Avogadro's number. Okay, if I want to find the number of molecules, I'm going to have to take Avogadro's number and multiply it by the number of moles. Okay, so somehow I have to get the number of moles from the information this question gives me. Okay, what it gives me is that this stuff is sodium sulfide, that's Na, which is a +1, with sulfur, which is a -2, so we're looking at Na2S, so 22.99 plus 32.07, right? Okay, and I've got to multiply the 22.99 by 2, because there are 2 of them there. Okay, so 22.99 times 2 plus 32.07 gives me a molar mass of 78.05 grams per mole. And the other thing the question tells me, little m, the mass, 29 grams. Okay, do I have less than a mole here? I do, right? 1 mole is 78.05 grams. I only have 29 grams. Is it okay if I get a decimal for n? Absolutely, that's okay. Just means I have less than a mole, and I do. All right, so n equals little m over big M. So for this one here, that's going to be 29 divided by 78.05. What's that?
0.37.
Okay, so sorry, I'm just going to have it on my calculator because I'm going to need the actual number. 0.05, so 0.35. Yeah, 87, so we'll say 0.359 is what we'll write, but we'll keep all of those decimals. Moles. Okay, then as we said, if I want to get the number of molecules, I take the number of moles and multiply by the number of molecules in 1 mole, just like saying 2 times 12 is 24 when someone asks me how many donuts I have in 2 dozen. Okay, so n equals, or sorry, not n, number of molecules equals 0.359 times 78, no, sorry, not 78, times Avogadro's number, 6.02 times 10 to the 23. And remember, that's got to be in brackets. E23. All right, so we're looking at 2.16 times 10 to the 23 molecules. For that one. All right, questions on that one? Who's anybody? Okay, how many people have done the fourth one? Okay, so we need a little more time on the fourth one still. So for number 4, okay, we're looking for what the mass is. So we're looking for little m. They tell us the number of molecules is 7.2 times 10 to the 23, so just over a mole, okay, of these, okay, is our number of molecules, and they tell us that the material is diphosphorus pentaoxide, P2O5. All right, so we got 30.97 times 2 plus 16 times 5 for our molar mass. So 141.94 grams per mole. Okay, for our molar mass there. And now we're looking for N, because N will help us to get the mass. Right? So N is going to be the number of molecules divided by the number of molecules in 1 mole. Okay, so we've got our 7.2 times 10 to the 23 divided by 6.02 times 10 to the 23. And if you know your math, since the exponents are the same, you can just divide the bases. If you didn't do that, that's fine. You'll get the same answer. Okay, so it's a shortcut on your calculator. Okay, so you don't have to put in the times 10 or anything like that. So divided by 6.02. All right, so our number of moles is 1.196. So 1.2. Or sorry, 1.2. Okay, moles. Obviously, we're going to keep all the decimals there, and now we're going to calculate what m is. N equals little m over big M. We're going to multiply both sides by m. That'll get us our mass. That'll get us our mass. I don't want that. Whatever that is, I don't want that. Okay, so we're going to take our molar mass, which was 141.94, and we're going to multiply that by our 1.2 moles, and that will get us our mass. So that times that. So 169.76 grams. Is our mass. You guys can go. Good luck. Sure, just put it in that stool there. Yeah, so hey, remember the key to victory in cross country. Run faster than everyone else.
Yeah.
Simple. It's a simple sport.
Run faster than everyone else you should.
Okay, listen up here, guys.
After cross country.
So, from your worksheet booklets, okay, I want you working on a few of these practice questions. Okay, they're pretty much like we've been working on. They're worded a little bit differently. They might look a little bit different, but they're exactly what we've been doing. Okay, I want you starting on question number 2, which is at the bottom of page 11 in your digital worksheet booklet. Okay, I'll leave this up here, but obviously if you're further away, it's harder to read. Okay, so that's what we're working on. Question 2, question 3, question 4. Okay, we'll be kind of just rolling along with those. Okay, for the remainder of the day today. Okay, as many of those as you can get done would be great. Okay, tomorrow we are going to forego the quiz. Okay, reason for that, you got a lab report due tomorrow, you got a reactions assignment due Friday, and they cut you a little break. Okay, you don't have to study for a quiz tonight. Okay, on top of all that. Okay. All right, so let's get working on this. Okay. Nitrogen is a special element, so we're looking at 2E here. Nitrogen's a special element. So when I look at the molar or the atomic mass of nitrogen on my periodic table, that's for N, one of them. Nitrogen comes as a pair, so you've got to put two of them there, so it's not 14.01. The molar mass of N2 is 28.02. Okay?